Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over the effect of pH on the solubility of salts. And so the reason pH would affect the solubility of a salt is because one of the ions is a base or maybe an acid from a base or an acid, a conjugate base of an acid or a conjugate acid of a base. And so if you have it in either acidic solution or basic solution, that could drive the solubility one way or the other, depending on what you have. So let's go over some examples. So here I have 3 salts, and the question is, which of these is more soluble in acidic solution than in the neutral solution? So what you want to be aware of, or what you're looking for, is whether the anion here is a base or an acid or neutral, right? So here you have barium fluoride, and the fluoride ion is the weak base of a weak acid. So you have hydrogen fluoride is your weak acid. So fluoride is a weak base. And so what would happen if you had an acid solution is that as this is dissolving, since the HF is a weak base or a weak acid, then the fluoride ion is going to be in equilibrium with the H plus. So very little of this dissociates in water. So as you are dissolving this, your fluoride ion is going to pick up hydrogen, the H plus ion that's in the acidic solution, and it's going to form HF. So as HF forms, it's taking the F out of solution, and so then it's decreasing the product F minus, right? So if we draw the dissolving of this, it would be PaF2 dissolves into Pa2 plus F 2F minus. But as the F minus is forming, as this dissolves, this F minus is picking up H plus going to HF. And so this is going to decrease, and as this decreases, more of it is going to dissolve there. So in this case, in acidic solution, BaF2 would be more soluble. So we could look at the same thing here, AgI. Here, iodine. So if we break this up into AgI, breaks up into Ag plus I minus. The I here is an anion of a strong acid, Hi. So this is a strong acid. This is the anion of a strong acid. So this is not going to do anything. So this is not going to be more soluble in an acidic solution versus neutral. It'll be the same. And then finally we have calcium hydroxide. Calcium hydroxide is going to dissolve into calcium 2 plus 2 OH minus. Here in acidic solution, this is a strong base. So in an acidic solution, this strong base is going to react with H plus that's in the solution, and so that's going to go away and form water, right? So as this decreases, this goes away. So as this is dissolving, OH is reacting with the H plus, making water, and so this is going away, and that's going to drive the reaction this way. So it's going to continue to dissolve. So calcium hydroxide is going to be more soluble in acidic solution. Okay, so I hope that's clear. What about number 2? Here we're given 2 salts and we're being asked which of these is more soluble in acid than in base. So again, you're looking at your ions here. This ion, CO3, iron here is iron carbonate, or I should say iron 2 carbonate, is going to dissolve into iron 2 plus CO3. Now CO3 here is a basic anion. It is the conjugate base of a weak acid, carbonic acid. So this would react, if you had H plus in solution, this would react to form your H2 CO3 acid, your carbonic acid. And so that would drive the solubility, the dissolution this way, so more of this would dissolve in acid. So this would be more soluble in acid than in base. And here, bromine, same thing going on here. So PbBr2 is going to dissolve into Pb2 plus 2Br minus. But Br minus, that's the anion of a strong base, HBr. So this anion is not really going to react with hydrogen or H plus, so it's really not going to form anything. It's not going to go away, so this would be neutral. So we would predict that lead 2 bromide is not going to be any more soluble in an acid than in a base. So I hope this is helpful. I hope this explains and shows how the effect of pH, what the effect of pH can be on its solubility. If you like this video, please like, share, subscribe, hit the notification bell, make a comment in the comment section, and thanks for joining me. I'll see you next time.